This is a pretty common electronics kit in an educational setting. Typically what you've got are many components mounted onto the board, labeled and identified with connection points. There's just some sort of a book that explains different examples of circuits and things that you can build, provides a little explanation as to how they function. And then accessory wires for making connections. It's all solderless, so if we had to hook these loose components up to make circuits, it would be very time consuming and the chance of making errors would be pretty high. So what they've done with this circuit is brought a spring out to every connector. And all you have to do is bend the spring and insert the wire between the coils. That makes a secure enough connection for electrons to flow. If you're going to connect more than one wire, this is not a good idea, bending the spring and putting it between the same coils. If you're going to connect a second wire, bend the spring a different way and insert the wire between different coils in the spring. And that makes sure you have a tight connection for each. If two wires are placed in between the same two turns of the spring, you may not get a good connection on either one, and they may be prone to slipping out. All of our circuits that we'll be working with in this example are low voltage direct current circuits. Direct current means that the polarity of the power source does not alternate or change places or change polarities like an alternating current. So the plus terminal will always be plus and the minus terminal will always be minus. For our power supply, we've got 6 AA batteries here. Most of the circuits that we're going to work with could be wired up with less, and we probably won't be using all 6 of these. But they're here if we get into a circuit that we want to use them. The connections for these batteries are made at the front right corner panel. And you can see between 120 and 121 we should have 1.5 volts. And the reason for that is a single AA battery is rated at 1.5 volts. So these are merely multiples of our 1.5 volt battery. So these 3 prongs represent the 3 batteries on one side, and these 3 prongs represent the batteries on the other side. Between 120 and 121 is 1 battery. Between 121 and 119 is all 3 batteries, and 3 times 1.5 is 4.5. Similarly, between 120 and 119 would only be 2 of the batteries, or about 3 volts, right? Because 3 plus 1.5 is equal to 4.5. So if the whole thing's 4.5, and this is 1.5, that means that this part has to be 3. And what we can do is we can use the multimeter to check the level of the batteries and see what kind of readings we get compared to what we know we should have. So on the multimeter, which is presently off, I want to measure something that could be somewhere between 1.5 volts and as much as 4.5 volts. This setting here for DC volts would max out at 2. Well, I might measure more than 2 volts. That means I should go to the next setting on the meter, which could max out as high as 20 volts. Now, if you measure something less than 2 volts on this setting, that's fine. You'll get a reading. You may not get as precise a reading as if you measured, say, that 1.5 volts or a 1/4 volt or something on this 2 volt setting. This setting would give you some more precision compared to this one. But we can't exceed the maximum rating on the dial, or we won't get anything show up on a display. So I will rotate this to the 20 volt max setting, and now I have 0 volts showing, and I have these 2 probes, and I want to measure the voltage at a couple spots and check out these batteries. Now in the case of these spring terminals, I might be able to get away with just hanging the probe inside the spring. For most connections, though, it would be necessary probably to use some alligator clip wires. So the red and black probes are making contact, and remember, we should have 4.5 volts there, according to the panel. And in fact, it reads more, 4.88 volts. Why is that? I just put in brand new batteries, and straight out of the package, they've got a little bit stronger voltage than what's specified. And this makes sure that the batteries will have a long, useful service life before they need to be replaced. So I have 4.5 volts there. I should have 1.5 volts here. And sure enough, 1.62, again, it's that fresh battery straight out of the package. And theoretically, I should have 3 volts between 119 and 120. Let's see what I actually have. I actually have 3¼ volts. Again, a little bit over because of the new batteries. So what I've done here is I've measured the voltage that the power supply, in this case the batteries, are able to provide a circuit. And if I want to do a quick check on the other side, the other set of 3 batteries, they all came out of the package together. 4.89 compared to 4.88 before. 3¼ volts, just like last time, on the other side. And if I check this setting, 1.62, just like the other battery on the other side.